So this is the part 2 of the discussion of the answers of the mock test. So let's start with the number 16. So we have here 7 over 9 that needs to be converted into decimal. So again, please remember that when you have a fraction that has a denominator of 9, the answer or the decimal conversion should automatically be a repeating number. So let's say for example, we have this 7 over 9. So we have here 7 over 9. Automatically, it's going to be 0.7777 and so on and so forth. Or you can also write that one as zero point 0.7 with a bar on top. And that's it. That's actually the answer. So maybe let's try it first to have a different example. So now what if we have 6 over 9? So same thing. It will become 0.666 and so on and so forth. We will make it 4 there or zero point 0.6 with the bar on top. Let's say, for example, we have two digits. So let's say we have 23. When it's two digit, it should have a denominator of 99 and then we have that one. So in decimal, it will become 0.232323 and so on and so forth. Or it is also equal to 0.23 with a bar on top. And then now what if we have like three decimal places? Three repeating numbers. I'm so sorry. So let's say we have 125 over 9999. So the answer is going to be 0.125125 that or that's also equal to 0.125 with a bar on top. Again, it means the number or the decimals are repeating. So I believe this one is already clear. We will proceed with the next number, 17. So actually, I just gave already an example a while ago, right? So I guess there's no need for me to further explain this one. So 75 over 99 is going to be 0.757575 and so on and so forth. Or that's also equal to 0.75 with a bar on top. Okay? I hope the first two items here are clear. Let's proceed to number 18. Okay, so estimate the value of the square root of 88 in one decimal place value. I mean in one decimal place. Okay. So sir, how do we do this one? Well, actually, I will change my approach this time because in your exam, right, it has actually choices. Okay. So let's consider we have choices. Okay. So this question, let's say we have A. The first choice is 9.2. B is 9.4. C is 9.6 and D is 9.8. Okay. So actually to further well actually what you can do here is to easily we can just like check the 9.2 times 9.2 and then see if what will be the product. Also you check the 9.4 times 9.4, check what's the product. Also you check the 9.6 times 9.6, you check the product. Also same thing with 9.8. Sorry. I cannot erase it, but I'll just. I'm so sorry. So we have here 9.8 because this one in this application, it's hard to delete the text. It's like I have to delete everything. Anyway, so that one. And then what we will do is like we will check their products and whichever would have the closest result to 88, that's gonna be the answer. Okay? But actually to do this one logically is we have to analyze where is 88 much closer to. Okay. I mean to say, when I actually write down a perfect square number line, is we have 1, 4, 9, 16, 25, 36, 49, 64, 81, and then 100. So where is 81 much closer? It's actually, sorry, I mean, where's 88 much closer? It's actually to 88. And that's mean to say, what's the square root of 81? It's 9. Square root of 100, that's 10. Mean to say, um, well actually, 81 is like, 88 is like much closer to 81. That's why our answer could possibly be 9.4 or 9.2. What we will do is we will try first these two. So let's multiply this. What's 2 times 2? That's 4. Carry 1. 2 times 9, that's 18. Plus 1, that is 19. 9 times 2, that is 18. Carry 1 here. And 9 times 9, that's 81. Plus 1, that's 82. And then we add 4, 7, 1, 4, 8. How many decimal places do we have? 1, 2. 1, 2. So it's 84.74. But we're actually looking for 88. That's still quite slower, right? Let's try the 9.4. Okay? 9.4. 4 times 4, that's 16. 6 carry 1. 4 times 9, that's 36. Plus 7, plus 1, that's 37. 9 times 4, that's 36. 6 carry 3. 9 times 9, that's 81. Plus 3, that is 84. And then this one here, 6. 7 plus 6, that's 13. 3 carry 1, that is 8. And then 8. How many decimal place? 1, 2. 1, 2. 88.36. And actually, this one is already much closer. And also, if we will try the 9.6, logically, the product of 9.6 by 9.6 is much higher than 88.36. But we're just looking for 88. Well, actually, this answer here is already good. That's why our answer to this question should be 9.4. Okay? And I hope this one is clear with you. Again, if you don't know this one, if you forgot about this, you can just go one by one with the choices. You square them and then you check which one would have the closest result or closest product to 88. Okay? We'll proceed. Well, proceed here. Number 19. Okay. 19. Arrange the following real numbers from least to greatest. Again, when you say least to greatest, small going big. Okay? Small numbers to big numbers. So you arrange them. And to do that one, actually my technique here is to you really have to convert all of them first into decimal. So let's start. What's the square root of 81? Obviously, that's 9. And then how about this one, this improper fraction, 26 over 3? So let's do the long division. 26 divided by 3. 2 by 3, that cannot be. So let's go right away with 26. 26 divided by 3, that is what? 8. 8 times 3 is 24. Oh, okay. And then we subtract, that is 2. Okay. You bring down here 0, but again, from the moment you put there 0, don't forget your decimal place here. 20 divided by 3, that is what? 6. 6 times 3 is 18. And then you still have here your 2 again, 6. Actually, 6 here is going to be continuous. So this one here is going to be 8.6 with a bar on top because 6 is continuous. Okay, the next one is the 6 plus pi. Okay, please take note that in our class, we will just be estimating, again, estimating the value of pi as 3.14. Okay, so we have here 6 plus 3.14. That's gonna be 9.14. So 9.14. So which one is the smallest? Obviously, the 8.6, and that is our 26 over 3. That's the smallest. The second one is actually 9. That's the square root of 81. And the largest one is the 6 plus pi. Okay? Well, actually, this is already the answer. Okay? And I hope this one is clear with you. Next one. 20. Evaluate 5x raised to 0. Okay. So please take note that in this question, the power of 0 only belongs to x. And what's our rule again? Any term, number, expression raised to 0 is always equal to 1. So what will happen here? This x raised to 0 will become 1. But don't forget that you still have your 5. So 5 and 1. Actually, that's multiplication, huh? 5 times 1 is 5. That's why our answer here is going to be 5. Let's continue. Number 21. Okay. Okay. Actually, don't be overwhelmed with this kind of question here, okay? Because there is a parenthesis. And after the parenthesis, there's a power of 0. It's like all of this number don't care about them anymore because all of them are being raised to 0. And any number, right? Any number, term or expression raised to 0 is always equal to 1. And that's it. That's the answer. Okay? Again, because there is a parenthesis in this given. Let's proceed. 22. Okay. Where did the power of 1 belongs to? To x. What is x raised to 1? That's still x. But you still have the negative 88 here. Well, actually, oops. The answer is still negative 88x. Okay? Again, this one here, when you have the power of 1, don't worry because you're just copying the answer. For example, you have 7x raised to 1. That's still 7x. You have 5 raised to 1. That's still 5. 7 raised to 1. That's still 7. So any number, term, or expression, or yeah, the raised to 1 is just the number itself. Okay? Let's proceed. Number 23. This one is under exponent product rule. And what do we do in product rule again? We add the exponents. But however, again, for the coefficients 5 and 12, since this is multiplication, we have to multiply them. What's 5 times 12? Ah, that is 60. Next, you copy the base x. What are the exponents? 20 and 15. So 20 plus 15, that is 35. And that's why the answer here is 60x raised to 5. That's x raised to 5, huh? 60x raised to 35. Okay, let's proceed. Evaluate. We have here 24x raised to 7, y raised to negative 3, all over 16x raised to 5, y raised to 3. Again, please remember that when you see a negative exponent or a base or a variable with a negative exponent, please bring it down. Or I mean, please put it on the different side. So if it's in the numerator, you bring it down in the denominator. So what will happen now is this one. It will now become 24x raised to 7 all over 16x raised to 5, y raised to 3, and then the y raised to 7. Okay? Again, sorry, that's y raised to 3. Y raised to 3. So the negative 3 became positive 3. I hope this one is clear. So let's continue first. Again, however, the 24 and 16, they actually have common factor, right? Am I right? 24 over 16. What's their common factor? That's actually 8 divided by 8 divided by 8. So we have here 3 over 2. That's why our new fraction would be 3 halves. Next, let's focus first on the x. This one is x raised to 7 over x raised to 5. Again, that one is quotient rule, huh? That's quotient rule. X raised to 7 over x raised to 5. And what do you do in quotient rule? You subtract the exponents. And that's gonna be x raised to 2. Next, you see here the y raised to 3 multiplied with y raised to 3. That one is the application of product rule. And in product rule, what do we do in product rule? We add exponents. Y raised to 3 times y raised to 3. That's equal to y raised to 3 plus 3. That is y raised to 6. And this one is our answer. Okay, I hope this one is clear. Let's proceed. Okay, evaluate the expression x plus x plus 10 multiply with x plus 5. Okay, please remember the template I taught you in this kind of question. Okay, when you just have here x and x, please take note of the template. X squared plus the sum times x, times x, and then plus the product. So let's use the template. So you put here x squared plus, what's the sum? That's 10 plus 5, positive 10 plus positive 5, that is 15. Just put the x. And then next, what is 10 times 5? That is positive 50. And that's already our answer. Okay? That's so simple. Let's proceed. 26. So, still same procedure. I mean, same template. X squared plus the sum plus the product. Okay? Again, this one here. Again, now this template is only applicable when you have here both x and x. This one cannot be applied when you have here 2x or 3x. Okay? We cannot apply when you have this. However, going back, this one will become x squared plus, what's the sum? What's positive 12 plus negative 6? 12 plus negative 6. It's like you have 12 pesos and then you have a debt of 6 pesos. All in all, when you pay or when you settle that debt, you'll still have positive 6 or 6 pesos. So that's plus 6. Don't forget the x. Forget the x there. And then plus product. What is the product of 12 and negative 6? That is negative 72. Well, actually, this one here, plus negative 72, right? Please take note that is also minus 72. I just missed this part. So x squared plus 6x minus 72. Because 6 negative 6 times 12 is negative 72. So we should not put here addition. Instead, subtraction. And that's it. That's actually the answer. Okay, let's proceed. Okay, actually, this one here has at I will discuss here two approach. Okay, so I will first use the template, the x squared plus the sum times x plus product. Okay, so we have your x squared. What's the sum of positive 7 and negative 7? That's 0, right? So it's like 0 times x, and that's nothing. So we can just disregard that one. Okay? Okay, but for purposes of explanation, I'll put here 0 times x plus, what's the product of positive 7 and negative 7? That's negative 49. So let's rewrite this. This one will become x squared. What's 0 times x? That's 0. Nothing. So we can just disregard that one. And this one here is negative 49. So minus 49. That's using our template. However, there's actually a rule that's identity called difference of two square. When you actually see this kind of given, you have x7, x7, and then you have your plus minus. The answer here is going to be, you just have to square the x and you square the 7. What's x squared? That is x squared, of course, and then 7 squared, that is 49. And then you just put here minus. It's always minus when you see this kind of given. So it's like, it's either you use this template or this identity. Okay, you will still have the same answer. This one. Well, actually, I taught you a technique for this one, right? Um, the one is the perfect square trinomial. However, maybe if you will still confused about that one, we can just use our template. The x squared plus the sum times x plus the... Ah, I just realized I can erase this. Anyway, so we have here x squared. What's the sum of 8 and 8? That is 16. That's positive 16. And then you put x. What's 8 times 8? That is 64. So plus 64. And that's it. That's actually your answer. So I guess to avoid confusion, we can just use this template if you want. Okay, let's proceed. Now, when you already have this given, 3x, right? That's not anymore the x and x. We cannot anymore use here the template x squared plus sum times x plus product. Okay, we cannot anymore use that one. Okay, and what we will use here, actually we can use here the perfect square trinomial. You remember that one? That a, okay, I'm so sorry. This one is not perfect square trinomial. This one is the difference of two squares. Difference of two squares. Because you see here, 3x, 3x, 5 and 5. And then, oops, what happened? And then, you see here the plus and minus. That is difference of two squares. And when you have that kind of given, what you just have to do is to square. You get the square of 3x, and you also get the square of 5. What's 3x squared? Huh? That is 9x squared. And then 5 squared is 25. So what you just have to do is, the answer to this one is going to be, just copy the 9x squared, just copy the 25, and then just put here minus. That's it. That's the answer. Okay, let's proceed. Now, what if we have 4x plus 6? Again, this one is still the same template, right? This one is 4x, 4x, 6 and 6. This one is sum and difference. Again, our result here will be difference of two squares. And what do you do again? We just get this. Again, now we're just using this one when we have here plus and minus. And then we have here the same 4x, 4x, 6 and 6. So I'll continue. So squared, 6 squared. What's 4x squared? That is 16x squared. 6 squared is 36. So just copy them. So 16x squared, 36. And then just put minus. That's it. That's the answer. Okay, let's proceed. Now, okay. Now what if we have our factoring? So we have here x squared minus 5x minus 84. So what do we need to do here? Again, x, x, and then you have to think of factors of 84 that could possibly have a difference of 5. Okay? So actually, those factor is going to be what? What are those factors? So let's say we divide, okay, actually, 84 is equal to 12 times 7. You can double check that one. 7 times 12 is actually 84. Okay? So I'll just put here 12. I'll put here 7. And then the result is negative 84, right? So it's either, we have actually two options. We have two options. It's either 12 is positive or 7 is negative, or 12 is negative, 7 is positive, because their product is negative, right? That's the only way. And then let's check which of these two would have a sum of what? Negative 5. What is 12? This one first, the first given. What is 12 plus negative 7? That is 5. But we're looking for negative 5. This one is actually wrong. Let's proceed to the next one. Negative 12 plus 7. That's actually negative 5. And that's why this one here, this is our factored form of the x squared minus 5x minus 84. Okay, let's proceed. 32. So factor the expression x squared plus 20x. Sorry, this would be 20x here plus 100. So this one actually is the application of the perfect square trinomial, because if you can actually observe, this one is an example of the perfect square trinomial. Sir, how do you know that? Actually, when I divide 20 by 2, I will get 10, and when I square 10, it's gonna be 100. When the numbers here, the 20 and the 100, or whatever numbers you put here, will satisfy this situation here, the given is a perfect square trinomial. Anyway, continuing with the factoring, so we have to think of what happened. You have to think of, okay, two numbers or two factors of 100 that wherein we can actually form that 20. So what do you mean by that? Actually, we can go right away with 10. Why? What's 10 times 10? That's 100. Actually, we can have here two possible ways to have a product of positive 100. It's either this one is positive and positive because positive 10 times positive 10, that's positive 100. Or negative 10 times negative 10, that's also positive 100. But let's check which one of those two will have a sum of positive 20. What's 10 plus 10? It's 20. And actually, this is it. Because this one here, negative 10 plus negative 10, that's negative 20. And this one is wrong. This one here is our answer. Again, because we're able to form the 20. Okay, let's proceed. Okay, maybe the last one for our part 2 because the recording is quite long already. Okay, so factor the expression 3x squared minus 7x minus 20. Okay, so I will admit it. This one is quite a bit would be a bit harder because you would be required to do this one to have a lot of trial and error in this kind of question. So let's continue. So we have your 3x squared, and the only factors we could, the only factors we could have to form the 3x squared could be x times 3x. Am I right? Okay. Because x times 3x, that's going to be 3x squared. So 3x squared is already satisfied. Now what we have to do is we have to think of the factors of 20. I mean negative 20. So what do you think we could have? We could actually have what? 5 and 4. Okay, let's check. What is 5 times 4? That's actually 20, right? But let's check if we can actually form here the 7. What's 5 times 3? That's 15. What is x times 4? Okay, this is 15x, sorry. Because what's x times 4? That's 4x. Actually, we cannot form here the 7x, right? We cannot form here. Because 15 plus 4, that's 19. 15 minus 4, that's 9. We cannot form there. What if we interchange? X, 3x. I will just copy, huh? And then I put here the 4. I put here the 5. Let's see. What's 4 times 3? That's 12x. What is x times 5? That is 5x. Can we form here the negative 7x? Actually, yes. Once the 12x is negative and this one is positive, when you combine them, that will result to negative 7x. Okay, how do we know the sign here? Where did negative 12x came from? Negative 12x came from 4 times 3x. And that's why this one should be negative. Positive 5x came from x and 5. This one should be positive. And actually, this one is already our final answer. And this ends with the part 2 of our discussion on the mock test. I hope this one is clear with you.